Does a disk full of movies get heavy? This is a question from the computer exam 20 years ago. The correct answer at that time was that both drives were equally heavy. But this answer is not necessarily today. What does this mean? Because around 2010, a new type of hard drive came on the market called a solid-state drive. It is called SSD for short. To answer the question above, the weight remains the same if it is a disk, and gets a little heavier if it is an SSD. So how much does a SSD loaded with movies gain in weight? Let's take an example: the world's largest ship called the Ocean Harmony, which is more than 20 stories high, as big as 4 soccer fields, and can house 9,000 people on it. If this 200,000-ton ship is our SSD hard drive, then after filling it with data, it is equivalent to it adding a piece of cold medicine so heavy on top of the original. So even though an SSD loaded with data will make the drive heavier, this weight change is something we can't weigh even with thousands of dollars of fancy scales. There is little that humans can do to really try to measure the difference in weight. Because there are so many interfering factors, such as any dust falling on it, it's already tens of thousands of times bigger than the difference caused by the data. This picture looks as if the movers are lifting a grand piano onto a truck, but in fact this is IBM delivering the world's first hard drive in 1956. In fact, the hard drive wasn't really sold because the price was so expensive that it could only be commercialized on a rental basis. The rent at the time was $3,200 a month, equivalent to $30,000 today. The capacity of the drive was only 5 megabytes. The image you see here is about 0.5 megabytes, and this audio is almost 5 megabytes. In fact, if we think back, the ability to record more information at a smaller cost and with less consumption is the mainstream direction in which we preserve information. The earliest records of information that appeared to man were painted on rock walls with mineral pigments, paintings painted by some ancient people about 30,000 years ago, and there was no possibility of moving things recorded in that way. By 6,000 years ago, in the westernmost part of Asia, the Sumerians had carved cuneiform characters into wet clay and then baked the wet clay dry, and this clay tablet was set in place to last for a long time. Each clay tablet weighed several kilograms, yet only a few hundred characters could be recorded. Later the carrier for recording words became lighter and lighter, parchment rolls, and paper, until it was developed to record with magnetic north and south polar properties. What used to take a gymnasium to hold an entire country's collection of books can fit on a 1 or 2 kilogram hard drive, and that's just an intermediate step in the process of preserving our information. We'll be preserving a lot more information for a lot less. So how far can we improve the efficiency? In fact, there is a ready-made, very good example in our body, that is, DNA. Almost every cell in the human body has a set of DNA data volume of about 3 gigabytes, and 1 gram of data in the DNA need more than 302 terabytes hard disk. How many grams of DNA are there in the human body? About 200 grams. So if we can reach the level of biological use of DNA to record data, the density of data preservation can still be increased tens of thousands of times. This is reassuring, but there is also something unsettling about. Is the new preservation method sound? Those clay tablets are bulky, but they are guaranteed to be clearly readable after more than 6,000 years. But the contents of the magnetic hard disk, even if properly preserved, 200 years later, the trillions of small magnets are still not honestly arranged in the same direction. It is really hard to say.